welcome to the Bristol Robotics Laboratory. I'm Chisan. I'm a microbiologist. Some of you might wonder what a microbiologist is doing in robotics lab. All robots need something in common to operate, no matter what size they are. Can you guess? It's energy. In our team, Bristol BioEnergy Centre, here we make energy using a technology called Microbial Fuel Cells. Microbial Fuel Cell, in short, MFC, is a biological battery that produces electricity using microorganisms. MFCs can be in many different shapes, but all share the same working principles. So, like this typical design, like conventional chemical batteries, MFC has a positive and negative end. We call them anode and cathode. In the anode, we have certain types of microorganisms that are capable of releasing electrons out of their cells. So when we give them food, they digest the food, process the food, and during the process they release the electrons out of their cell if the condition is set for the purpose. And in the MFC we capture that electrons, and the flow of electrons is electrical current. So what can we do with these MFCs? Here are examples, a series of robots called Ecobot. This first generation Ecobot was built nearly 20 years ago in 2002. This one had 8 MFCs here on the top, and this one was the world's first robot that running on sugar that biologically processed. And then this is a second generation Ecobot. This one had 8 unrefined biomass, such as dead flies and rotten fruit. And these two robots, they sense the light and move towards it when enough electricity was produced. This third generation Ecobot was built 10 years ago in 2010. This one has 48 fuel cells here, so again different shape to the previous ones, and these more power enabled this robot to feed and hydrate itself. So let me explain how this works. Here we have a robot stomach, and this robot attracts flies. So once a fly was captured inside by a chemical, it gets slowly digested in this robot's stomach, and the fly juice will go into all 48 fuel cells. So this is very, very similar to a living creature. So these robots are very special because these robots are not run on chemical batteries. They are like us, they eat food. Would you like to learn more about MFCs and what we do in our lab? You are very lucky today, because usually we have very limited access, so only in the lab to go in, because of the potential contamination, biological contamination. But because it's a virtual, you can get in. My colleague Ivona will show you inside the lab more interesting work we do. Come follow me.
Hello, welcome into the lab. My name is Ivona, and I will tell you a little bit more about what we can do with energy stored in organic waste and how microbial fuel cell can convert it into direct electricity. Let's have a look in here for a moment. This is a microbial fuel cell made of ceramics. This is a ceramic cylinder which holds anode on the outside made of carbon fiber. It's held by the wire which we connect over here, and inside of that microbial fuel cell it's the cathode. Cathode needs oxygen. If we put that microbial fuel cell into a chamber and fill it up with organic waste, and here I've got synthetic urine. So for example, I can add that liquid into the anode. So this is where the microbes will colonize the electrode, converted into electrons. Let's see if we can power a simple motor. This is a windmill toy with just very simple motor inside it, and let's see if one microbial fuel cell can power this windmill. I will just connect. This is the anode, this is the cathode, and it actually operates that motor directly from one single microbial fuel cell fed on waste, on synthetic urine in this case. Let's have a look what other things we can do with this energy. Here I've got something far more sophisticated. This is an Ecobot, exactly the same as Jason presented to you before, made out of 8 microbial fuel cells. These have anodes inside this 3D printed chamber with the anode wire coming out over here. This is the cathode. Cathode needs to breathe oxygen, and we connect it via resistor. However, here those fuel cells are connected together in series, and they charge a small capacitor on board of that Ecobot, and this stored energy is then used for the Ecobot movement. This Ecobot's got 2 photosensors. That means that it detects light and it moves towards it. It performs phototaxis. Therefore, this energy created on board in the microbial fuel cells can be used to move and also to send us information about the environment. For example, it can detect what temperature or what humidity is in our lab and send us the information directly, send us the data of that environment that this Ecobot is actually in. So this is the self-sustainable, organic-powered robot. Let's have a look about everyday items. We can power motors, we can power robots. How about our everyday items? How about a phone? Can we charge a mobile phone? And here is very similar principle. We've got a demonstration that it is urinal, that we can put synthetic urine inside, and behind that urinal, let's have a look. You can see over here there's an array of microbial fuel cell. We call it a stack. So it's a group of microbial fuel cells put together to generate electricity. Then this electricity is stored within those capacitors. If we press the button, then the energy stored in those supercapacitors is being released to charge our mobile phone. It can be also our tablet or everyday devices that we use every day as a storage possibility within the capacitor, which are very similar to batteries. Therefore, all those different devices and applications we can definitely power with microbial fuel cells that process organic waste. And now I'm heading to Jason again, that she will tell you a little bit about this application.
So the last piece of work I would like to show you today is will be hopefully very exciting opportunity for you in near future. So far you've seen MFCs, what MFCs can do, powering various applications such as robots and mobile phones. How about we have, what about we have these MFCs in our houses? What if all the building walls were made of MFCs? If so, we can treat our waste, and at the same time that will give us power to use on site. So that's why we designed the fuel cells like this, looking like bricks. And at the moment we are currently building a website, biodigital interface. So through this interface, when all go functional, you can go to the website and interact with these fuel cells in real time, and your actions, such as feeding microbes or warm heat or cool them, your actions will you will see the microbes respond to your different actions. This website, this work is currently under construction, but when it's ready, we will to it. So if this sounds interesting and you want to have a go, then please follow our BRL Twitter feed, and we hope we will meet you there once again. This is it for today, and now we are able to take some questions from you. Thank you for the visit. That's good. Hello again. We moved to this office to have a quiet environment to answer to your questions if you have any.
Yes, happy to take any of your questions or queries you might have about the research in BBiC, and happy to hear from you here on this platform. We would be able to stream that live feed from our lab again in more or less 5 to 7 minutes. So hold on to us, and we will be back again shortly with the stream live from our lab.
Thank you.